Sulfur. The chemistry of sulfur differs from that of oxygen the same way as phosphorus differs from nitrogen. The electronic configuration of sulfur is 1s2, 2s2, 2p6, 3s2, 3p4. It forms compounds with an oxidation of -2, just like that of oxygen, but it can also form compounds with oxidation numbers +2, +4, and +6, unlike oxygen. Its electronegativity, 2.44, is less than that of oxygen at 3.5. Atomic size at 104 picometers is larger than that of oxygen at 73. The major industrial chemical obtained from sulfur is sulfuric acid. Sulfur occurs in the Earth's crust to the extent of about 0.05%. It is mostly found in rocks as metal sulfates and sulfides. It is found in its elemental form in large underground beds. Another source of sulfur is H2S, present in natural gas and crude oil. Sulfur exists in two different allotropic forms, crystalline rhombic and monoclinic forms. Rhombic form is a pale yellow solid and is stable at room temperature. Monoclinic form is stable only above 370 Kelvin. Both forms consist of 8 sulfur atoms, S8, combined in a ring form, but the rhombic and monoclinic sulfur rings are symmetrically different. Extraction of sulfur. Sulfur is extracted from underground deposits by pumping superheated waters, 440 Kelvin, down the beds to melt the element and blowing out the molten sulfur with compressed air, known as the Frasch process. The sulfur is then extracted from the underground sulfur-bearing rocks. This is done by sinking concentric pipes deep into the ground. Sulfur layers typically lie 160 meters down under the layers of sand and gravel. Superheated water at 440 Kelvin is forced down the outer pipe onto the sulfur, which is melted. Compressed air is then blown through the inner pipe, forces the molten sulfur to the surface where it is allowed to solidify. A purity of 99.5% is obtained by this process. Sulfur can be extracted from natural gas by separating out hydrogen sulfide gas. Hydrogen sulfide is absorbed in monoethanolamine and then converted into sulfur by the following reactions. You can see the reaction of the hydrogen sulfide with oxygen or SO2 to extract the sulfur. Most of the sulfur produced is used in the manufacture of sulfuric acid. Sulfide ores, when heated, give off sulfur dioxide gas, SO2, that is directly used for the manufacture of sulfuric acid. Sulfur is used as fungicide and insecticide in agriculture. In rubber industry, it is used for vulcanization of rubber. It is used in medicine for the manufacture of sulfa drugs and in certain skincare ointments. It is used in the making of matches, gunpowder, and fireworks. Hydrogen sulfide. Hydrogen sulfide is a foul-smelling, poisonous gas. It is produced from metal sulfides. Metal sulfides are formed when sulfur reacts with metals. The reaction below demonstrates two examples of the formation of metal sulfides, one between iron and sulfur and one between tin and sulfur. The metal sulfides react with acids to give hydrogen sulfide gas according to the reaction below. So these free protons from the dissociation of an acid produce the hydrogen sulfide gas and the metal ions. Most metal sulfides are insoluble in water, with the exception of those formed from group 1 or group 2 metals. Their solubility is controlled by the hydrogen ion concentration in the solution. The reaction of sulfides with acid is usually conducted in Kip's apparatus for the generation of H2S in the laboratory. A diagram of Kip's apparatus is shown on the next slide. So here's a diagram where we would put our solid iron sulfide or metal sulfide as an example. From here, we would pour our acid, in this case HCl, so we would have hydrogen ions. As the H2S gas is generated, it'll be collected here, and the remaining liquid and aqueous ions in the solution will be collected here. The solubility of sulfide metals in acidic solution makes them useful in qualitative analysis for the detection of cation radicals. 2 examples are shown in the reactions below. So, copper ions in solution in contact with the hydrogen sulfide gas will form a black copper sulfide precipitate, and if instead I have zinc ions, a white precipitate. Another method for generating hydrogen sulfide is by heating thioacetamide dissolved in water, according to the reaction below. This is our thioacetamide, aqueous, so dissolved in water, which will generate hydrogen sulfide gas. This method of generating hydrogen sulfide gas can be used to supply hydrogen sulfide for qualitative analysis. Sulfur oxides. 2 important oxides of sulfur include sulfur dioxide, SO2, and sulfur trioxide, SO3. Sulfur dioxide is formed by burning sulfur in air or roasting metal sulfides in the presence of air, according to the reactions shown below. So the sulfur in the presence of oxygen, this burning, will generate this sulfur dioxide, or roasting metal sulfide. So here's a metal sulfide roasting in the presence of oxygen in the air to produce sulfur dioxide. It is also prepared by the action of concentrated sulfuric acid on copper, silver, or mercury, as seen in the example. So the example is showing copper, which will result in the production of sulfur dioxide. Sulfur dioxide, SO2, is a colorless gas with an irritating and suffocating odor. In qualitative analysis, when an unknown salt containing sulfide is heated in the preliminary test, the smell of sulfur dioxide is an indication to the presence of anion sulfide. Large amount of sulfur dioxide gas is released into the atmosphere from coal and oil-based power plants, oil refinery operations, and copper smelting plants. The emission of SO2 causes severe environmental pollution. It forms an acidic aqueous solution and acts as a reducing agent. Sulfur trioxide, SO3, is formed by direct oxidation of sulfur dioxide with atmospheric oxygen, according to the reaction below. Sulfur trioxide is used primarily in the manufacture of sulfuric acid. Sulfuric acid, contact process. The manufacture of sulfuric acid is based on the catalytic oxidation of sulfur dioxide. The whole process takes place in a series of heating, precipitating, washing, cooling, and drying tower units in the system. Dry SO2 gas is passed through an arsenic purifier to remove traces of arsenic dust impurity, and finally through a testing box known as a Tyndall box. The dry, purified SO2 gas is then passed over the catalyst contact chamber. The sulfur dioxide is then converted to sulfur trioxide according to the reaction shown below. The above reaction is slow and reversible. Optimum conditions are maintained with a finely divided V2O5 catalyst, 2 atmospheres of pressure, and 723 Kelvin and excess oxygen. In the absorption tower, the sulfur trioxide is absorbed in 98% sulfuric acid, forming fumate sulfuric acid, or oleum. Oleum is then diluted to a desired concentration. Oleum is a colorless, dense liquid with a specific gravity of 1.84 at 288 Kelvin. It freezes at 283 Kelvin and boils at 590 Kelvin. It dissolves in water with the evolution of large amount of heat. Hence, care must be taken while preparing dilute sulfuric acid from concentrated acid. The concentrated acid must be added slowly to water with constant stirring while diluting. Formation of sulfate salts. Chemical reactions of sulfuric acid are a result of several of its characteristics: low volatility, strong acidity, strong affinity to water, and ability to act as an oxidizing agent. Sulfuric acid ionizes in water as follows. Sulfuric acid forms two salts, sulfates and bisulfates, or hydrogen sulfates and acid sulfates. A test for sulfate can be conducted using soluble barium salts when added to a solution containing sulfate ion, forms a precipitate of barium sulfate. You can see that here. So I have a potassium sulfate, an aqueous barium nitrate will form a solid precipitate of barium sulfate. This precipitate is insoluble in mineral acids. Dehydration. Sulfuric acid has great affinity for water. Substances not only lose their water of crystallization, but also lose elements of water from the substance themselves, according to the following. So glucose, C6H12O6, we can remove 6 water molecules from that and are left with 6 carbons. Formic acid, if we remove a water, we're left with carbon monoxide. Ethanol, if we dehydrate that, remove water, we're left with C2H5O, C2H5, an ether. Sulfuric acid is used as a dehydrating agent and drying agent for gases. Other uses of sulfuric acid include the manufacture of dyes, drugs, explosives, paints, synthetic fibers, and detergents, the manufacture of fertilizers, the manufacturing of acids such as HCl and HNO3, the refining of petroleum, in metallurgy, and in storage of batteries. Sulfurous acid. Sulfurous acid, or trioxosulfuric acid, H2SO3, is a colorless, pungent-smelling liquid. It is an intermediate species causing acid rain from sulfur dioxide. It is used as a reducing agent and as a disinfectant. It is used in the manufacturing of various paper products. Other uses include in the making of dyes, pigments, drugs, explosives, detergents, and in metallurgy. The salts of sulfurous acid are known as sulfites and bisulfites. Some bisulfites are naturally occurring, as in wines. Sulfites are used in food preservation.